So we want to talk about factoring the sum and difference of cubes. So before we do that, let's just kind of take a look at what is a cube. What does it mean to cube something? So to cube something is to use multiplication 3 times. So if I'm looking at 2 cubed, that's really 2 times 2 times 2, or 8. If I'm looking at x cubed, that's really saying, okay, take x times itself 3 times. So if I'm looking at x to the second cubed, that's saying take x to the second times itself 3 times, or that's x to the 2 plus 2 plus 2 is x to the sixth. So when we're looking at cubes, our perfect cubes here are any number times itself 3 times. So we have 1, 8, 27, 64, so on and so forth. And you should be familiar with the first few perfect cubes here and be able to recognize them on sight. When we're talking about perfect cubes of variables, we're looking at any exponent that is a multiple of 3. So like x cubed is x to the first cubed, x to the sixth is x to the second cubed, x to the ninth would be x to the third cubed, so we're looking there at multiples of 3. So really, just in generic, x to the 3 times any number is a perfect cube. All right, so we have this kind of generic formula here for how to factor these sum and difference of cubes. So if we have the sum of cubes, a cubed plus b cubed, then it's going to be a plus b times a squared minus ab plus b squared. So what we really are needing to determine here is what is our a value, right? What did we cube to get the first term? And what is our b value? What did we cube to get the second term? And the difference of cubes is pretty much the same, except it's going to be a minus b times a squared plus ab plus b squared. So the formulas are essentially identical except for the signs, and a shortcut to remember that is the kind of acronym here, SOAP. So it's same, right? So the first sign is always the same as what the original binomial had. So if sum is positive, and then opposite, right? So it's the opposite sign. So if we have a sum, the second sign is going to be negative. If we have a difference, the second sign is going to be positive. And then the end sign, the last sign, is always positive, right? It's a squared, so it's always going to be positive here at the end, plus b squared. Right, so how do we factor these? So if I'm looking at this guy, this is a sum of cubes. So what we really need to determine is looking at that first term, what did we cube in order to get that? Well, to get x cubed, we cubed x. And then we're looking at our second term, and that's going to give us our b value. What did we cube to get 8? Well, we cubed 2. So now we know an a value, we know a b value, and we can just substitute directly into our kind of formula here. So we would have a plus b, which in this case would be x plus 2, then times our a squared, so x squared. And now minus a times b. So a times b is x times 2, or more properly written as 2x, so minus 2x. And then plus our b squared, so that's 2 squared, or 4. And you just want to double check always when you're done with factoring if you can factor any further, and in this case we cannot, we can end there because we don't know how to factor that any further. So we'll look at another one. We're going to do the same thing. So we're to determine what did we cube in order to get the first term, x cubed. Well, in order to get x cubed, you cube x. What did we cube in order to get the second term? Well, in order to get a 64, you cube 4. And in order to get y cubed, you cube y. So now we have our a and our b values, and we can just substitute it in. So this time we're working with a difference. So we're looking at this one. So our signs should be negative, positive, positive. But otherwise, substituting it is the same. So we're going to have a minus b, or x minus 4y, times a squared, or x squared, plus a times b. So that's going to be plus 4xy, and then plus b squared. So plus, just be careful when you square b, make sure you're squaring the whole thing. So 4 squared is 16, y squared is y squared. All right. So let's do a couple more. Take a look at these. So it's always a good idea to still be on the lookout for your greatest common factor. So in this case, we do have a greatest common factor of 4x squared. So we want to factor that out before doing anything else, because currently looking at that, I can't really do much else to it. All right, once I factor that out, now I have a difference of cubes. So to get 125, I would have cubed 5. To get x cubed, I would have cubed x. And then to get 1, you just cube itself, 1. And we can then go back and substitute in to our nice formula. So this is a difference. So I'm going to start with subtraction, right? Same sign. So 5x minus 1. Then my a squared. So 25x squared. And then this is the opposite sign. So we started with a difference, so we should have addition here. A times b, 5x. And then, again, always positive, b squared, which is 1. And just double check you can't factor anything further, and we can't, so we are done now. Okay, so we want to look at factoring completely. So really this should always be our goal no matter what we're doing, but we just want to make sure when we're factoring completely to just always be checking our factors to make sure that we can't go any further. So I'm going to start here with a GCF. Right, I'm going to start with a GCF. There are actually two different ways to approach this problem now. One way will allow you to factor a little bit further, and that's looking at this as a difference of two perfect squares. And the other way, you won't quite be able to factor as far, but it's equally as correct. We don't really have a hierarchy for whether or not we do a difference of perfect squares first, or what this is also is a difference of two cubes. So I'm going to treat this like a perfect difference of perfect squares first. So what I'm going to say is this is really x times, all right, that's going to be x to the third plus 1 and x to the third minus 1. And I'm going to do kind of both scenarios so you can see what the difference is. Now we have two cube problems, right? A sum of cubes and a difference of cubes. So this is going to be x times. For the sum of cubes, my a would be x, my b would be 1. So we're going to have x plus 1 and then times x squared plus, excuse me, no, not plus, minus, so we have the opposite, minus x, and then plus 1. Now for the next one, our a would be x, our b would still be 1, but this time we're working with a difference. We're going to have x minus 1, x squared plus x plus 1. So slightly different just by the signs. And then we're fully factored. Now what would happen if we treated this as a difference of cubes rather than a difference of squares first? So let's look at that. I would have factored out my GCF. All right, now I can treat this as a difference of cubes. So we're going to have x times my a value would be x squared, my b value would be 1. So we'd have x squared minus 1 times x to the fourth, right, x squared squared. Let's see, plus x squared plus 1. Now I have a difference of squares here. This x squared minus 1 is a difference of squares. So I'd have x times x plus 1, x minus 1, and then times that trinomial. So while this is different, it's not wrong. Just what's going on is that we don't know how to factor this trinomial yet. It will factor into these two trinomials. As we can see, that's the difference between these, but that's just not something that we know how to deal with. And that's fine. So whichever way you do this, just show your work. My suggestion would be try it as a difference of two squares first in general, and then that'll just help you factor further on down the line. All right, let's look at another one of these. So here we have a trinomial, so we're just going to factor it like any old trinomial. So it's going to factor into two binomials. My first times my first needs to equal my first. So x cubed times x cubed would equal x to the sixth. And then we need two numbers that when we multiply, we get a positive 8. But when we add, we get a negative 9. So say minus 1, minus 8 there. All right, so now we have two differences of cubes here. So we're going to want to factor each of those individually. So for this first one, my a would be x, my b would be 1. So we'd have x minus 1 times x squared plus x plus 1. Now for the second one, my a would be x, my b would be 2. So we would have x plus 2, excuse me, yeah, minus 2. Sorry, we're dealing with two differences here, x minus 2, and then times x squared plus 2x plus 4. And then just double check if you can factor any further, and we at the moment cannot, so we're good to stop there.